Hello everybody, welcome to lecture 11. This is the lecture for week 8. We've only got a couple more lectures to go, and this and the next two lectures are going to discuss statistical analysis and types of statistical analysis. I'm going to use examples in SPSS just to give you a little bit of a hand when you're thinking about assessment 3. This should give you, this and the next couple of lectures should give you hopefully as much information as you need to be able to complete assessment 3, but also feel free to refer to the textbook. If you haven't already arranged access to the program, the data analysis program SPSS, then you really need to. It's available on campuses, all CQU campuses. If you have any troubles accessing it on a campus, then please let me know, because I've been assured by the computer people that it is there. You can also, I think, acquire a 14-day trial of SPSS, which may enable you to do the analyses that you need to, but you will need to manage your time quite carefully. And obviously, if you get to the end of the 14 days and you haven't finished, then you're going to probably have a few troubles. I think that's probably the main thing. You can purchase SPSS as well for, I think, $50 from the CQU bookshop. However, seriously, for the amount of analysis you need to do, once you figure out how to do it, it's probably not that necessary to purchase an entire copy. Okay, so I'll get going on this because it's a reasonably decent sized lecture. Okay, so in this lecture I'm going to talk about descriptive analysis and inferential analysis, which is population estimates and hypotheses. The reading for this is chapter 12, and it's really quite useful. There's also some help on these types of analysis in the Statistics Learning Centre, which I'll have links to on the Moodle page. Okay, so we've stepped back a step. Last lecture we discussed preparing or presenting the final research report. We've given that a bit of a whirl, but now I'm just going back and giving a bit more extra information on analysing data that's designed to give you a hand with your assessment. Okay, all right, so there's 5 types of statistical analysis. There's descriptive analysis, which describes the data, talks about central tendency, which is things like mean and median, and variability. And inferential analysis is talking about reaching conclusions based on evidence and reasoning. So taking what you think about a sample and actually understanding the potential error around that and putting it out to a larger scale to try and draw inferences from a sample to make conclusions about a whole population. And that includes testing hypotheses. And then next lecture and the lecture after, we'll be talking about difference analysis and then association analysis, and then predictive analysis is quite complex, and I'll probably leave that one alone because we don't really need to go into it at this level. Page 317 of the reading can give you a little bit more information about that if you're seeking it. Okay, so straight into descriptive analysis measures. Okay, so central tendency measures the typical response. Mode is the value that appears most often. Median is the value that lies in the middle of an ordered set of values. So it's the middle one, and the mean, which you probably know all about, is the sum of values, the average divided by how many, so mean is the average, it's the sum of values divided by how many values there are. So there's a series of numbers for you, the number of n, so n is the number of values, and there's 15 numbers there. The sum of those numbers is 201. The mode of those that's the most commonly occurring value is 2. The median is 8, that's the middle number because they're listed in order, and then the mean is 13.4. Okay, variability. So that's central tendency, as I was discussing. Variability talks about typical difference between the values, okay? So you're just looking for really straight up percentages and differences between those. So frequency distribution is a tabulation of how many times values appear. The range is the distance between the lowest value and the highest value, and the standard deviation is the degree of variation in diversity in the values on a normal distribution curve, which we've discussed in the previous lecture. So I've just given you an example there of a frequency distribution table. This is from my research. So my sample was 28% resort people and 35.2% backpackers, but there were hardly any people staying in B&Bs. Straight up, you can observe some really key differences in that sample, and that gives you some fodder to talk about. So you can say, oh, well, you know, this has got a high percentage of backpackers. This might be because we administered the survey in areas where there's a high usage of by backpackers. So you can actually start drawing some thoughts and conclusions. Okay, I've given that same set of numbers again. N again is 15. The mean is 8.9. It's not 8.9 because I think I did it before and it was 13.4. Sorry about that. Good on me. So anyway, whatever the mean is the sum of adding all of those up together and then dividing it by 15 because there's 15 of them. The range is the span of numbers, so 40 minus 1, top minus bottom is 39, okay. The sample standard deviation is 13.43. Maybe I've calculated, silly me, I think I've accidentally put the wrong way around. So anyway, hopefully, I'm sure that you understand this anyway. Please contact me if you don't. Okay, so you can use the standard deviation calculator. That's what I did to get this. So you can just click on that and you put in your parameters and your details and it'll give you the standard deviation, which is S, and that's the formula for it as well. So that big E there, if you don't understand, that's sum. Okay, so it's a sum of each value minus the mean squared over the number 15 minus 1, and that's the square root of that. So it's quite a complex formula. If you're not super confident with maths, you're probably better off just using a calculator. Okay, descriptive analysis measures. Right, okay, so when to use what? This comes straight out of the textbook. Have a look at it and have a read around it if you want to. It's on page 323. So this just gives you a bit of an idea of what descriptive statistic you should use and when. So whether you should use central tendency or variability. There you go, it's pretty straightforward. Okay, frequency, distribution and mode. Okay, right, so this is in SPSS. I can't see because I've got a little screen there, which I'm not sure you have. Okay then, so descriptive analysis in SPSS. How you conduct this? Now I've done this in real time in the tutorial, so if you want to have a look at it actually happening as I'm clicking it, you can go back and have a look at that. I think that's in week 6. But this is how you do it in terms of just giving you instructions. Okay, so to calculate the frequency distribution and mode, you select Analyze from the menu bar. This might look a little bit different on your computer. I use a Mac, so this is how it looks in a Mac. I think it's fairly similar across Mac and Windows, but anyway, you can work it out. So analyze, descriptive statistics, and then frequencies. Okay, so this is to find your frequency distribution in your mode. All right, number 2, so once you click on frequencies, it'll come up with a window that looks like this. It'll ask you to select which variable, so you have a list down that left-hand side, and that's all the different variables available that you have in your SPSS database. You can find the ones that you want to analyse, and these are nominal ones that I've chosen, so these are named ones. So this is your gender, male or female, your age group, you know, under 20, 20 to 30, etc. And then education level, so, you know, didn't finish high school, finished high school, got a diploma, got it, etc., etc. So you select the things that you would like to find the frequencies about, whichever one. You can pick as many as you like, and it'll just give you a table for each one of them. And then you click on statistics. which then brings you up. So that's the old window in the back there. That brings up this new window, and you just click on mode for this to find the mode. All right, so, and then you click continue and OK. And you get an output window, which shows up as a different window. It sort of opens itself up. On the left-hand side, you can see a navigation pane, which shows you how to find things. And then you have your outputs. Strange, those arrows are going through the middle of that. So you've got your output. So here you can see for your gender, you've got the N, so how many? You've got valid, 523, 522, 510. So not everybody answered the education question. And one person, and not everyone answered all of them, but particularly 23 people didn't want to answer the education question. And then you've got your other outputs, which is here you've got your frequency tables, so you can see that particularly your percentage is really interesting. So valid percent, we had 45% male and 46% male, 54% female. Age group, same deal. You can see that, you know, I had a high proportion of backpackers. So interesting, not very surprisingly, I've got a high percentage of 20 to 29 years. So you can see that 44% of the sample in my research is backpackers. Is age 20 to 29, which correlates with the typical profile of a backpacker. That's interesting. That's the sort of stuff that you pull out when you want to think about discussing things in reports. Okay, you can also select charts to produce graphs. So if you go back a couple of steps here, when you're selecting things, you've done statistics and gone in there and come up with this. You can also go into charts while you're sitting here at statistic, you go into that window, come back, go into charts then, and come back. And you can select the same things again. You can click on charts and it'll bring up what type you like. In that case, I've chosen bar charts, and I like to see my bar charts in percentages. So I selected percentages and then continue. That then produced another output of a whole bunch of graphs. And those graphs show me, you know, more clearly what I could see in the figures. So obviously I've got a huge percentage of 20 to 29-year-olds, and they're also degree qualified, which is quite a high proportion of degree qualified people, which is also interesting and gives me fodder to discuss and talk about when I'm writing my report. The other thing you can do if you don't like the graphs, which I didn't when I was doing my report, if you don't like them, you can actually copy. So you can just right-hand click on the output window in SPSS, copy it and paste it into Excel. And then you can create, sometimes it doesn't paste exactly right, and you have to make sure all your headings are right and so forth, and then you can actually just make a graph. Now, can I just draw your attention to this graph, and same with these graphs. They have a title, they have axis titles, they have labels on the axes as well as titles, so you can actually understand. Now, this only says age group. I would prefer to have a proper title. So it's really important when you're writing anything, any kind of report, and you're referring to graphs, that you show a proper title that makes sense so you understand what you're looking at, you label your data, and it's figure 1 or graph 1 or table 1 or whatever you want to do it. It's written as table 1, and it's not just there for decoration. You also need to write in your actual report as shown in figure 1. It's no use putting in a graph. I'm not going to look at a graph if you haven't referred to it in your text. Okay, so you have to say, figure 1 shows that there's a high proportion of 20 to 29 years, etc., etc. Okay, you are not to put a graph in or a table or any picture or anything unless you're actually explaining it and referring to it in the text. Right, okay, now descriptive analysis. So now we're talking about mean, standard deviation and range, okay? So if we want to calculate these things, we can go into descriptives. Now, so you just click on analyze, descriptive to statistics, and then descriptives. Okay, that will bring up this window. I chose 3 variables that had a Likert scale rating, so we could calculate a meaningful mean. So the P1, and P3 are all images that respondents were asked to rate on a like-it scale from 1 to 5. Okay, so you click on so you select those, you click on the arrow. That's pointing backwards, that arrow there, because that's giving you the option to put them back on the list if you don't want them, or you select them in the left-hand list and click the arrow which points the other way when you're selecting that list, and that puts them in there. Then you click on options. You can, at the very top is mean. It's usually already selected. In this case, all of the things that we really wanted were already selected by default. You click continue and OK, and that brings up this new window. And you can see again there's the navigation page. It's starting to show you the long list of things that you've done, so you can go back and look at them if you need to find them. Okay, these are the outputs. So for P1, 521 people rated P1, 524 rated P2, and 520 rated P3 in the survey. Maximum minimum, obviously not very useful for us, because we know that, well, I guess, you know, maybe nobody rated it a 1 or a 5, but usually someone does. So they're a maximum minimum on our scale. Our mean is a really interesting thing. Okay, as you can see that picture 1 is actually far, far more preferred than pictures 2 or 3, or not far, but relatively more preferred. And it also shows us the standard deviation, which is important as well. Okay, right, so that's it. That's descriptive statistics. And you can do the same thing with graphs. You can go in and select charts as well to display those, and you're welcome to have a bit of a fiddle with that. Right, okay, inference analysis. So inference analysis is really about drawing conclusions, as I said before, drawing conclusions about a wider population from a sample. To be able to do that, you need to be able to talk about error and the error and the possible plus or minus of the value that you're giving. Sorry, I'm not making a lot of sense here, am I? Okay, all right, so sample statistics are values computed from the sample. Parameters are values that are from a complete census, all right? So a statistical inference is a procedure where the sample size and sample statistic are used to estimate the population parameters, okay? All right. Okay, so this is a poor picture, a quality picture, but it's actually quite good. Okay, there's different symbols used for parameters versus statistics as well. Okay, so we want to know about the population. So we take a random selection, which is sampling, which we've already done. We have those to work with, and we can produce a sample mean. But using inference, we can identify what we think a population mean is within certain confidence intervals. Right. Okay, there's two types of statistical inferences. There's parameter estimation, which uses sample information to approximate the population value through the use of confidence intervals. That uses the sample statistic, which is usually a mean or percentage from the sample. So it's just a standard, you know, like I said before, 44% of my sample is this. It uses the standard error of the statistic, which is the measure of variability in the sampling distribution. And it uses the desired level of confidence, which is the degree of accuracy required, stated as a range within an upper and lower boundary, so plus or minus. Okay, so that's parameter estimation, and then hypothesis testing is used to compare the sample statistic with what is believed or hypothesized to be the population value prior to the study. So I might say that, well, actually I do, I think that our an image is rated really highly, so I hypothesize that it's going to be rated this, and then I can do a test and see if it actually supports that hypothesis, the data actually supports that hypothesis or not. Okay, so hypothesis testing is based on the idea that you might not be able to actually prove something is true, but you can potentially prove that it, disprove it as well. So that's also important. So your null hypothesis might be that all apples are red, and the way you can disprove that is by proving that maybe not all apples are red, which is an alternative hypothesis. Hope that makes sense. Okay, All right, variability in the sample directly affects the standard error. You can see this here. So standard error equals 4 when it's flatter and there's more distribution across. So, but when everything's clumped around one similar kind of value, then the standard error in this case is 2, so it's much lower. I hope that also makes sense. Oh, and you can see that explained more in page 335 of the textbook. Okay, so to conduct inference analysis in SPSS. Okay, so mean standard deviation and standard error. Okay, so these are the things that we need to calculate. Going back here, standard error and levels of confidence. Okay, so we take our data yet again. We click on Analyse, compare means, and then the one sample t-test. We select which variables we want to analyse and we leave the test value to 0. Okay, so in this case, I've just chosen image 1 to make it quite simple, and you click OK. Okay, so you select OK to get your output, and this is what you end up with, a t-test. Okay, so you have for image 1, 521 people rated it, as we knew already. The mean rating is 4.18, which we also already knew, but the standard deviation is 0.806. But now we also know the standard error mean, which is 0.035. It also tells us the confidence interval boundary. So the lower, within 95% confidence, we can say that the lower boundary is 4.11 and the upper is 4.25. Okay, so in this case, oh no, actually this is the next one. All right. So that gives you, so that's pointing out to you the information that you need to get from that t-test. Okay, a hypothesis test is based on the sampling distribution concept. Okay, read more about this on page 343. Okay, but you can see here, this is just using an example that was in the textbook. You can see here that this is the distribution of responses. Okay, so it's got this idea that the central tendency, right? So this idea that most of the responses are going to be clumped around this sort of central point. So in this case, in this image, the rating mean was 4.18. Okay, so 4.18 is going to be the hypothesized mean. Okay, so sorry. So 4.18 is actually the sample mean. So in this case, mine's it says here, okay, I'll go with this. Hypothesized mean is $2,750. The sample mean is actually $2,800. Okay, so that $50 difference between 2,750 and 2,800 computes to plus 1.43. Okay, because 1.43 is less than 1.96, which is the standard acceptable error that we use with a 95% confidence interval, then you can see there that this is actually supports this hypothesis that of 2,750. The mean does actually fall within an acceptable range. And I'll also point out just up here the hypothesis test and p-value. If you want to have a look at Statistics Learning Centre, there's a link there for you to look at that. Okay, now I'm going to explain this by using an example from my data. So I'm sorry, I probably should have, I'm introducing this to you and now we can go through it a bit more clearly. Okay, oh sorry, and back there too, rejection region on both sides of that curve as well. If the sample mean was at 2,900 maybe, I think, might be outside of that. I don't know, I haven't done the actual calculation of the computation, but if the Z value became 2, for example, then that's in a zone where you have to reject the hypothesis. Okay, so this is from page 343 of the book. This is the 5 basic steps involved in hypothesis testing. Okay, so this discusses both hypothesis testing for a mean and for a percentage. When they're talking about Z being plus or minus 1.96 or plus or minus 2.5 standard errors, don't get confused. I'll just popped in table 10.3 in the bottom there. That's just to remind you that if you're working on a 95% confidence level, then you have the 1.96 as your standard error, and if you have 99%, you have 2.58%. 2.58 as your standard error. So you, it just depends on what level of confidence you actually choose to use. Right, so I'll give you an example of how this actually works in SPSS, okay? So to do a hypothesis test, this is a very simple one. You select analyse, compare means, and then a one sample t-test, so the same as before. Okay, now you select which variables you want to analyse and propose a hypothesis for the mean in the test value window. Okay, now P1 has been rated out of 5 on a like it scale, as I said before, and my research suggests that people will like it. So from other things I've read, literature and so forth, there's a lot of natural elements in image 1, and I know that people, it seems to be the sort of thing that people would like, so I've hypothesized that the test value is 4, okay? So I have put in a test value there of 4. Now I could put in 4.5. If I think it's going to be really fantastic, I can do that too, okay? But I've just said 4 just for this example, okay? So I can then click OK. And this is the information it gives you. Now, I know this looks like a bit of a dog's breakfast, and I'm sorry about that. I wasn't exactly sure how better to do it. Hopefully you can follow me, okay? So we've got our output, all right? We've got the t-test, the one sample statistics table there. It shows us the mean for image 1. The number is 521 again. The mean is still 4.18, so it's still giving us all the same information. Standard deviation and standard error mean. All information that was provided in the previous one. Okay, so I've just shown that you could see that there. All right, now the output table, this next one, indicates that the test value is 4. So it's a little bit hard to see, but test value equals 4. So this is what I'm testing for, okay, in this table. It shows the 95% confidence intervals as showed before. The mean difference of 0.177 is there. It's calculated by subtracting the sample mean from the hypothesized mean, okay? And it's just given a couple more decimal points. Okay, the t-value, or for our purposes, we can consider that the z value of 5.001 is determined by dividing 0.177 by 0.35, which is the standard error or mean. Now, 5.001, and that's a z value. What's that telling us? Is that more than 1.96? And the answer is yes, it is. So it falls outside of the curve, outside of this bell curve here by miles and miles. So my hypothesis was very wrong in this case. Okay, and the two-tailed significance level is 0.000. Okay, so that tells us how, if we're getting close, so there's absolutely no significance in this result, so it's going to be 0, 0, 0. If I did this again and I estimated 4.13 or something like that, that significance will show me just how strong the significance is, and that will give me an idea of how confident I can be that I've hypothesized that value to be close to what it actually is. So in this case, my sample finding does not support the hypothesis I had. Right, this is the final slide. Okay, so reporting the results. So have a look at page 345 in the book as well, because that can help. Basically, when you're thinking about doing all of this and this analysis, and I know I've rushed through it. I'll talk through it in more detail when we're actually in the Zoom lectures, because then I can actually fiddle with it and show you different ways you can do things. But when you're talking about this stuff, you've got to be really clear, because not everybody understands these concepts, and you need to just explain with enough information for people to be confident that they know that you know what you're talking about. Okay, so the key points when you're reporting these results is to report on the interesting and important information, okay? And think about this in assessment 3 as well, because that's what I want, interesting and important, all right? Okay, what's interesting? It's good to discuss difference. What story did the sample tell us? What story, what did we find out? What can we understand about the sample? What story didn't the sample tell us? Did it maybe, for example, I've got practically no B&B users in my sample, so it's not telling me what B&B users want, even though I'm fairly confident there are a lot of B&B users in Cairns. They're not the people that were answering my survey, so that's important information. And it also gives me the opportunity to identify what further information we need. So I can then say it might be useful to do further analysis on this. Okay, important. Show that the findings are significant and within what confidence intervals. Okay, so the book goes through this little example, and it actually gives you an example of how you should report hypothesis tests to managers and to clients. So you state the hypothesis, you perform the hypothesis test computations for the mean or percentage, whatever it is. So you show how you've arrived at it. You determine if the hypothesis is supported by comparing the Z value with the critical Z value. And here we go, 1.96 for a 95% confidence level. If the hypothesis is not supported, compute confidence intervals to provide appropriate confidence intervals. So you could actually show if the value is within this, then it's acceptable, and if it's not within this, it's not acceptable. So show a range. And I think that's actually the end of the lecture. I hope I haven't gone too fast. I know it can be a little bit complicated, but if you work through the examples, hopefully it'll make sense for you. All right.